Alright, so I can have the timer and the slides in front of me. And this one, we're gonna make it full screen, like so. Okay, so good afternoon, everyone. I'm honored to be here today to discuss a topic that is not only fascinating, but also critical to our understanding of the current and emerging threats in the digital world. This presentation will delve into the increasingly sophisticated realm of cyber threats on social media. Focusing on malvertising, we're going to be talking about some deepfakes and the scams these technologies are used in. My name is Andrei. I'm a graduate in automatic control and computer engineering, and I'm working as a software developer at Bitdefender doing cyber threat intelligence. I'm generally passionate about all kinds of investigations and regularly dive into subjects that require either open source intelligence or digital forensics. I'm also a teeny bit nervous, as this is my first talk, but hopefully everything is going to go smooth. This is the agenda for today. I'm going to go over a short introduction to the digital threats that we see on social media. Then we're going to see some examples we've seen in the wild. Right after, I'll be discussing some evasion techniques used by attackers, as well as mitigation techniques that could be employed by defenders. Lastly, we'll end the presentation on some future predictions about the state of social media, as well as what we, as users, can do to protect ourselves. So, before we begin, who here in the audience uses social media in any kind of form? I see a lot of hands. Nice. So, if you do, have you ever seen any kind of dubious content? And I don't mean questionable memes that people share sometimes on there. Because if you did, then this presentation is for you, because I'll be providing some behind-the-scenes details into the attacker methodology, how they're doing it. But if you didn't, then this presentation is also for you, as in today's talk, I will take you all across the board of social media malvertising, providing an introduction to everyone. So, I'm going to be focusing on three specific types of attack, the first one being malvertising. And here, I'm not talking about just ordinary deceptive ads. I'm talking about malicious advertisements, specifically promoting fake AI-based solutions. Like, imagine ads promising revolutionary AI technology that, in reality, is a front for malware. Next up, I'm going to be talking about the exploitation of AI in order to create deepfake content. This involves how actors are using AI technologies to generate realistic audio and visual content, impersonating either public figures or celebrities to misspread information or to promote fraudulent products. The last thing I'll touch base on in terms of attacks will be the scams that are proliferated through social media. And these are not just random phishing attempts. I'm going to be showing some well-orchestrated campaigns designed to exploit the viral nature of social media, spreading scams, I would say, pretty rapidly across networks and often employing even social engineering to maximize their reach and impact. So, having said that, let's go over each one in detail. I'm going to be starting off with some examples, and here you can see some examples of ads that promote some of these AI tools that I've been talking about. We see AI tools such as Midjourney or ChatGPT, and one thing we can notice is that these ads garner quite a few reactions, some of them reaching up to 10,000 or 20,000 reactions. We also have ads that feature almost none, and these are a side effect of a tactic that actors employ, the constant creation and rotation of ads, which I will be providing some details soon enough. As some of you, of course, might think, most of these reactions are bots. Of course, these are there in order to instill trust in users. But upon closer inspection of the accounts that are reacting to such posts, we see that there are also legitimate users who like or comment, and even some unfortunate people who are downloading and running these kinds of demos or AI solutions. By the way, you can see even attackers engage with these kinds of people, answering their questions and trying to seem as legitimate as possible. As far as this level of AI impersonation goes, which kinds of ads, you might ask yourself, do we encounter? Well, we have encountered the following fakes for families, such as AI families, such as ChatGPT, Google Gemini, Google Bard, products like Photoshop or DALL-E. But there's also a trend of entirely fabricated tools, such as AI Creator, tools that are crafted to sound innovative and lure those eager for the latest in AI advancements. In terms of how these actors operate, one prevalent method stands out. They are using URL shortening services. These platforms, such as RingPop and TinyURL, are usually instrumental for bad actors. These serve as a disguise, of course, for distributing malicious links under the guise of simplicity or convenience. Of course, these links are used to obfuscate the direct link which users are accessing. Let's say if you have something that's stored on Google Drive, for instance, or to mask a series of redirects that the user will be put through. These shortened URLs are often embedded in these social media posts, sometimes advertisements, and even the pages about information, making it challenging for users to identify the legitimacy of the link at a glance without clicking on it and testing it first. We also find that storage services play a crucial role in these attacker strategies. Services like Google Drive and GoFile, along with platforms such as GitHub, Bitbucket, or GitLab. These are often used as repositories for malicious content. These platforms are chosen for their reliability and for how easy it is to create accounts and to store data on them. Imagine finding one of these repositories that store malware, then watching the attacker in real time, his commit history, as he's trying to update his malware to avoid detection. Pretty interesting stuff. So, when we get to some numbers, you might be wondering, all right, we all know that scams exist. Scams have existed for quite a while now, but we must ask ourselves, how far is the reach of these scams? Well, attackers don't just create new pages, they're also taking over existing pages with sizable fan bases and then rebranding them. Rebranding them means that they're either replacing photos or posts or ads. Here we can see an example of a page that was taken over, one with 2.5 million followers. The attackers, of course, started running ads right away for an account verification tool, yet another creative way of trying to distribute malware. But we also see pages like this one that I'm showing you right now, pages that are started from scratch, clone pages from already existing ones, but nonetheless, even if they are clones, you see that they manage to gather even 1.2 million followers. One particularly interesting aspect here is that you can, for those of you who don't know, you can actually merge pages on social media and choose the metadata from which page you want to keep. So, if imagine an attacker takes over a page with 1.2 million followers and 1 million likes and creates one of these clones. He can then merge the two pages and choose from which page he can keep the followers and the likes. Therefore, he's able to, so to say, distribute the new page to a very sizable audience without going to too much trouble. For just this particular case, when we're talking about AI impersonation, we've seen over 500 ads with consistently changing languages and targets. And some of these ads garner quite the attention. Just one of these, just an example of these, having reached up to 120,000 people. That's quite a number for a single ad out of those 500. Now, of course, it's clear not every click means a download, and not every download means that someone ran this software. But out of so many people, given the fact that we've seen some comments, we must ask ourselves that maybe even if 1%, just one person out of 100, chooses to run this malware, that could lead to quite a few people getting infected. And now that we've seen some of these ads and the reach, we must turn our attention to how these attacks work. Well, attackers are generally using storage services in conjunction with parameters that allow them a one-click download from the social media platform that displays the malicious ad. And this is what's called a drive-by download, because the user isn't shown any kind of information about the file they're about to download, leaving them unable to verify its legitimacy without clicking. Here, in this scheme, we can see just that, how an attacker can push a malicious ad to social media, and with just one click, the malicious file is saved to the user's computer. Of course, not every attacker uses these means of operation. We've also seen pages, entire pages being cloned with the same purpose, distributing malware, like in the image I'm showing to you right here. Now, I want to do just a small exercise. I'm going to be showing you two screenshots and asking you which one of them do you think is the real one. This is the first one. As you see, it's a screenshot of the New York Times. This is the second, another screenshot of the New York Times. And these are them side by side. Anyone care to venture a guess of which one is the real one out of the two? The first one. And you would be correct. Do you want to share why?
Because the first one has more details, and the second one on the right side has only faces of the person. This means that maybe built by AI.
All right, I see your point. These are actually taken at two different times, the articles themselves being all legitimate. The one thing that could have given this one away is either the lack of a subscription button that was in the right side corner of the image, or the domains. Because, of course, every user will look at the domain and easily figure out which one is the real one. But let's consider another example. Let's imagine, for instance, that we pick a random letter, let's say the letter E, and replace it with an identically looking letter, but with a different Unicode. Some of you might know this is what's called the homoglyph attack. And as you can see, this would make it a lot harder for users to spot the odd one out. One interesting fact about this is that when ads are rendered on social media, you might expect that the URL is replaced with its Punycode version, like you'd expect for the second one to be replaced with the Punycode version. That's actually not what's happening. The URL is being rendered as I'm showing it to you. So imagine scrolling Facebook and seeing the actual NewYorkTimes.com in the address down there. That's one of these interesting details that attackers abuse. Next up, we're going to be taking a deeper dive into the malware families that these attackers use. They often deploy these families to steal personal data, of course, either cookies or login information, but I'm going to be detailing for each one the most interesting aspect. First up, we're going to start with Relight. This is a stealer that uses a particularly interesting strategy by masquerading as a legitimate browser extension. One fact I would like to add here is that you might remember those comments I've shown with users saying that my install failed at 90%. Well, imagine one of these executables is ran, and suddenly in your Google Chrome extension list appears such example of a Google Translate extension. We all know that these extensions are not by default visible in the right corner of Google Chrome. They are actually added to the internal list. So these users might not have even noticed that anything changed on their computers. They might have just ran the malware, thought that the installer failed, when in reality a new extension has been added to their browser, one that steals browser cookies, their browser history, their login credentials, and can even make screenshots of their browser. Next up, we have Nova Stealer. This one represents an alarming trend in the malware ecosystem, and that is the malware as a service, which some of you might have already heard about. This model dramatically lowers the barrier for cyber criminals to access and deploy sophisticated malware tools. This stealer is currently being developed and operated by a French-speaking actor known as Nova Sentinel. What's particularly interesting about this one is that it exemplifies the commercialization of cybercrime with subscription models that make potent malware accessible for as low as $6 a month. So that's cheaper than McDonald's. We have another example, Vidar, which focuses primarily on cryptocurrency wallet data and browser cookies. A particularly intriguing aspect of this stealer is its command and control communication strategy. Unlike typical malware that communicates directly with a control server, Vidar initiates its first server contact through seemingly innocuous platforms, such as, for example, a Steam profile or a Telegram channel. This method cleverly masks its malicious communications with normal web traffic, complicating detection efforts. As we can see in this image, the malware uses the Steam name-changing feature as a mechanism for command and control updates. We see that each username includes an IP address and a pipe symbol. This pattern allows for dynamic updates of the CNC server IP without altering the malware's code on the infected machines. So basically, the attackers, simply by changing their username on Steam, can point their infected machines to a new server instantly, as fast as the old one gets taken down. Next up, we're going to be pivoting to the topic of deepfakes, which are a more sophisticated form of cyber threat that leverages AI in order to create convincing fake videos, fake audio, or fake images. These deepfakes are being used in a variety of scams. The attackers are generally trying to manipulate public perception and promote fraudulent schemes across several domains. These have become a tool for illicit activities in areas such as cryptocurrency scams, stock investment scams. Here, by using the likeness and voice of trusted figures and celebrities, scammers create fake endorsements or mislead people with investment advice that can appear startlingly authentic in these videos. Furthermore, deepfakes are being used in product scams, where fake testimonials or reviews by well-known celebrities are crafted in order to sell products that may or may not exist or that do not perform as advertised. Here, I'm going to be presenting a small demo. This is one taken from a forum where some actors are advertising their business of creating deepfakes for social media. And of course, I don't have the sound. I guess no one from sound is around for that. It's the age-old. I tested it and it worked before this presentation, and now it doesn't seem to be doing so. Well, I guess there's no point in fretting over this. It would have been nice to hear these people promote or take on the average crypto bro persona and promote all kinds of investment scams. But I guess we're just going to have to move on without that and go on to some numbers, some alarming numbers, I would say, because those were just a few examples of deepfakes. We have identified more than 3,000 of such deepfakes used in ads in just the last couple of months, but we expect this number to be even higher as we continue our research. We've also identified quite a few public figures being used, the number going up to 18 different public figures for Romania, to give a local example. These figures promote all kinds of scams, either healthcare, either crypto, either investments, either malicious executables that are disguised as premium software, or even just demos to existing software. These deepfakes are not confined to any single language. Their reach is becoming global, and it's impacting audiences across linguistic boundaries. This widespread application further complicates our challenge of detecting and mitigating these threats. I've identified deepfakes crafted in quite a variety of languages, including but not limited to the ones that I'm showing on the current slide. And of course, as you can tell, given the ease with which content can be translated these days, there's no limit to the number of languages that the attackers can craft their ads or their content in. This multilingual approach, imagine that it allows perpetrators to target specific parts of the population with or leveraging cultural nuances or the trust people have in certain people's advice or opinion. Imagine selecting parts of the population for different healthcare scams, choosing different personas, and with the ChatGPT that we all know, attackers can easily use it to translate their content into different languages and also ask it about which kinds of people he can target. Of course, as the difficulty for the automatic detection increases, also does the difficulty for creating convincing deepfakes for the attackers, as a deepfake model created for a specific language currently struggles at generating content in a different one. That's a fact that we've noticed in the wild, as attackers are trying to use models for languages with a similar Latin background. One such example would be Romanian and Italian, languages that share a 77% similarity, lexical similarity. The result of these attackers being a deepfake that was easily discernible for audiences that knew either one of those languages. It's clear that it's becoming concerningly easy for attackers to get themselves a few deepfakes to use in their scams, with some forums offering, as you can see, not only deepfakes, but support to the less experienced attackers in running their malicious campaigns, as well as teaching them how to avoid detection on social media. This particular forum offers, for the low cost of $3,000, help for an entire team for a month, team that would create your deepfakes, that would help you with social media exposure, that would help you with SEO, with search engine optimization. They would help you promote your scams as well as distribute them. And some of these teams have went as far as being able to put you into details with other people you can sell your data that you gather to. So, from the current landscape of digital threats, it's clear, as it always has been. We all know social media trends are constantly evolving, but so is malvertising. The scale of these campaigns is increasing by the day, with just one social media page hiding entire infrastructures, complete with ways of obfuscating and evading as many detection methods as possible. This was a graph that I initially wanted to add to my presentation that I later turned into a meme because I've seen that it's way too hard to see. But all of the details that are added to this presentation are things that we would have talked about over this graph. Remember that this is just one page running one or more ads with such a complex architecture behind it. Multiple languages, multiple executables, multiple distribution platforms. In a case local to Romania, we've seen a combined ad reach of 1.5 million people on a mystery box type of scam. A number reached from just a few pages that employed complex architectures like the one I've showed before. This particular scam employed a hidden subscription-based model that was fronted by a one-time only type of payment in order to receive affordable products. We've seen this particular type of scams across multiple countries as well, as attackers are trying to leverage the popular e-commerce distributors known in these particular regions. As these cybercriminals evolve their tactics, one of their key strategies is evading detection by sandboxes. Some scammers employ a variety of methods to detect whether their web page is being opened from social media or from a different environment, and they code their servers accordingly to change their behavior in order to avoid exposure. These types of evasion include, for example, using the user agent string. Scammers can use scripts to check the user agent in order to determine if traffic is coming from a particular type of device, let's say from a mobile phone, in order to choose whether they will display the malicious or the safe page. Of course, they can use IP addresses and they can change the content of the page. They not only translate it, but they're also able to change the entire content, such as the people promoting the scam, the deepfakes used in this particular page based on the zone from which you are accessing that particular page. They also use query parameters and social media metadata. This is a particularly interesting example because if you've ever clicked on an ad on Facebook, you would have seen that Facebook adds a few parameters to your new URL, the URL it redirects you to. Well, attackers have went as far as checking these parameters, whether they exist or not, and returning either safe or malicious pages, extracting the Facebook client ID and checking to which person they are actually showing the particular page. And here, we can see one such example of this heuristic behavior with a particular server that checks the user agent from the device accessing it. Here, it returns either a malicious page if you're opening from an Android or an iPhone. That screenshot is taken from a spoofed browser with an Android user agent, or if you're opening it from a personal computer or a PC. That particular page, translated, has no content that could make it seem like a scam in either fashion. It's just random information from the internet. Of course, when a sandbox will try to access that particular domain, the sandbox most likely runs on a user agent from a computer. So a safe page will be returned, and the URL would be marked as all right. These cybercriminals not only focus on evading detection by security tools, but also they actively work to circumvent, let's say, the reporting mechanisms of social media platforms. This helps them in maintaining the longevity in their scams and in increasing their reach without being flagged or taken down. So here are a few examples of how they manage to stay under the radar. These scammers usually try to keep a low number of ads active at any given time, the maximum being usually 4. This strategy helps them prevent drawing too much attention to their activities, reducing the likelihood, of course, of getting reported by users, and fewer ads also mean that can be more closely monitored and tweaked if needed. They also use 12-hour rotation of ads. By rotating their ads every 12 hours, that means changing which ad is active, which ad is inactive. One example you can see in the page, in the photo I'm sharing. Scammers ensure that no single ad accumulates enough views or engagement in order to trigger social media algorithms or manual inspection. This frequent rotation makes it difficult for patterns to be established either by users who are watching these ads or by automated systems. They also employ the daily creation of new ads. Of course, each day new copies are being created. This tactic involves slight variations, though, in the ad content, such as changing in wording, images, or layout. These small modifications can significantly affect the digital footprint of this particular ad, helping it evade filters designed to catch previously identified malicious content. And last but not least, we have the ad metadata obfuscation. Scammers will often try to obfuscate the metadata associated with ads, metadata which includes information like the creator of the ad, the target audience, the engagement statistics, anything that could give any hints towards which part of the population is being targeted. That, of course, is being done in order to avoid flagging by automated systems that scan for these types of inconsistencies or known indicators of scams. What can we do to mitigate all of these behaviors, you might ask ourselves? Well, in order to effectively mitigate the impact of malicious ads on social media, we can leverage a variety of automated detection technologies and strategies. First of all, we can turn our attention to identifying the content of the ad. This technique would involve analyzing the content of advertisements using machine learning models that are trained to recognize patterns indicative of scams. These models can scrutinize text, images, overall ad layout, as well as what the person in the deepfake is saying in order to detect such suspicious elements that might suggest fraudulent intent. We can also see URL analysis. Automated systems can perform an in-depth analysis of URLs embedded within ads. This process includes checking, of course, the URL against known databases, as well as examining the structure of the URL for suspicious patterns and conducting real-time analysis of the web page content to which the URL redirects. We also have deepfake identification using AI. And by that, I mean convolutional neural networks in particular. When it comes to deepfake technology, these networks are particularly effective in analyzing visual content to distinguish between genuine and AI-manipulated images or videos. And by training these models on vast data sets of both real and synthetic media, they can learn to detect subtle cues in this type of content that can help differentiate deepfakes from authentic videos or authentic media. Also, we have the last method, which is the last possible method, which is end-to-end account validation and classification, being the most interesting one, in my opinion. This comprehensive approach involves validating and classifying social media accounts to determine their authenticity. This approach would include the assessment of posts, of ads, but also the information of the base account, such as the account age, the engagement patterns, and the network of connections, in order to identify likely fraudulent accounts. This classification would be useful in preemptively blocking ads that frequently engage in suspicious activities. Next up, I'm going to dive in a little deeper into some of these things that I've mentioned before with some more technical details. As far as the ad content identification goes, natural language processing techniques can be used to analyze the textual components of advertisements, providing a powerful tool for detecting potentially malicious or deceptive content. Here, we can use NLP to determine the subject matter, for example, of an ad. By understanding what an ad is promoting or discussing, systems can flag content that aligns with common themes of known scams, such as get-rich-quick schemes or unauthorized health claims, as we've seen. This would involve, of course, parsing the text in order to recognize keywords and phrases typically associated with deceptive practices. NLP techniques can also be used in order to identify sensational or overly persuasive language, to grab attention and elicit quick reactions from viewers. These NLP algorithms can be trained to spot language patterns that deviate from normal, such as exaggerated claims like once-in-a-lifetime opportunity, click now before it's too late. Examples that we've all seen before. As far as the effective mitigation of ads, this would mostly involve the understanding of the broader context of where these ads are being posted from. Specifically, analyzing the authenticity and the intent of the social media pages themselves. So, not just the ads. When we're talking about a takeover page, for example, we should be looking also at the content of the page itself, at the content of the ads, and at the information behind that page. This process would start with an analysis into the page's about information. That information can be used to verify the legitimacy and consistency of what the page claims to represent. Here, discrepancies or missing information often are red flag indicators of fraudulent schemes. Also, identifying the general theme of a page or the focus of one such page, that would involve understanding the typical content and the audience engagement of that page. This identification process can use both text and the visual content of the page in order to determine if it consistently, over a period of time, adheres to the purported theme originally suggested by the page we're analyzing. And last, and the most important factor, would be the post and ads clustering and the topic classification. Of course, when we think about a page, we see in our minds all of its content. Here, we should think about clustering posts and ads based on their content with automated systems. Here, this clustering would help in assessing whether the content being advertised aligns with the usual content shared by the pages, which is critical, in my opinion, in identifying whether those pages have been hijacked or taken over ahead of time, ahead of, for example, being merged with another fraudulent page in order to take over the page's metadata. For instance, we can imagine a page that typically discusses sports and wellness. Of course, if that page suddenly changes content, if that page has a post about crypto or about something that is totally unrelated, this would be a red flag indicator that this page has been compromised and that it's going to begin showing ads like the ones we've seen. Or just start engaging in deceptive practices, promoting certain URLs, certain articles, or other products. So, after everything we've seen, we must ask ourselves, what's the current state of the social media threat landscape? What's going on right now? And what could happen tomorrow? Until now, in this presentation, we've went over scams that promote crypto investments. We've seen healthcare scams. We've seen malware promoted on social media. And these are just some of these examples we've identified. But we must also turn our vision to what may happen tomorrow. As I've shown you, it's getting dramatically convenient for new threat actors to start creating such scams, to employ entire pipelines of ads, of malware, of control of other computers and accounts. Imagine, as we've seen some of these stealers, you might have noticed that all of them are targeted towards browser cookies, mostly. That's because a lot of attackers in these browser cookies usually, besides financial data, target also other social media accounts. This way, they manage to spread from page to page. And more concerningly, if some attackers could get access to pages of businesses that run ads, they, of course, get access to also the revenue that the legitimate users have added for these ads. So they can immediately switch the old ads with theirs, essentially for free. What can we see when we think about what might happen with all of the improvements we see to these algorithms of deepfake creation? Well, first of all, as this technology becomes more widespread, more accessible, and of course less expensive, as we've already seen some actors or attackers already promoting this kind of creation of deepfakes for a pretty low price. We anticipate, of course, a significant rise in their number. This technology lowers barriers for malicious actors, making it easier to produce and distribute fake content. We also expect an uptick in deepfakes involving political figures, manipulating the people's view on certain political agendas. As this technology improves, it's clear that as the deepfakes become increasingly convincing, it will be increasingly easier to create more personalized and believable content to target certain audiences. We can also expect to see more advanced pig butchering scams. For those of you who don't know about this type of scam, this is a scam prevalent to social media apps such as Tinder or Bumble, where victims are usually fattened up, so to speak. That means the attackers engage them over a long period of time, gaining their trust, even giving them money in order to get them to deliver them one final blow in the form of a scam. And as the creation of deepfakes becomes easier and easier, we can expect easier interaction with these users. Imagine not interacting as it was until now through images or messages. Now, attackers can create deepfakes, can create entirely new people who never existed in order to talk to you and gain your trust on these apps. Last but not least, the technology of voice cloning can be used, and most likely will be, in man-of-the-middle attacks. This involves intercepting communications, like phone calls, let's say, and using cloned voices of trusted individuals, as some of us have already seen some articles of people who have already fallen for that. Of course, this type of scam would not involve creating an audio from zero. Imagine talking to someone you know, talking for like 3 minutes on a phone call. That person asks you to do something, or your boss asks you to do something, and some key details are inside that 2-minute conversation. Imagine attackers deepfaking the voice of your friend in order to change only 2 or 3 seconds. That will drastically change the outcome of what your friend wanted to share with you. Given what could happen, we must ask ourselves, what can we do besides all of the technical stuff? Well, first of all, when interacting on social media, of course, we must be attentive to details, especially the particularities of the videos that we are watching. We have to check the content of the pages that deliver us ads. We should also search for online promotions where we see ads on social media. So the next time you see a golf set for only the modic sum of $10, payment only for delivery, you should also check the website that the scam would point to in order to maybe validate its legitimacy. And always we should be mindful of the downloaded media. When it comes to social media and these drive-by downloads attacks that we've seen, it's clearly very easy to download either demos or content that, of course, is a front for malware. So, as always, we should be mindful of what we get on our machines. Thank you, and now it's the time for the Q&A session. While the Q&A session happens, I'm going to switch to the thank you slide because it's more interesting, or at least represents how I'm feeling when I'm analyzing these types of attacks on social media. So, questions, anyone? If not, yes, we have one there in the second row.
So I'm really curious about what type of tools do you use to actually analyze these campaigns on this large of a scale?
Well, fun fact, that graph that I've shown you, the really big one I've turned into a meme, started with an ad that I saw myself while browsing social media. Usually, when trying to organize myself, I use any type. I'm guessing the question refers to what tools I'm using to organize all of my data, or well, the workflow is quite an interesting one, actually. Usually, it starts from just seeing one of these ads on social media. That's why anyone can really do that. When you see one of these ads, of course, the ad usually has some text, or the ad comes from a page. The next step we could do is check that particular page and see what ads the page is running. Then from that, we can pivot into searching more of these ads by the text content that resides inside of them. Imagine, for example, I've shown you one example of an ad of Midjourney. There it said that you can download Midjourney, of course, a demo of it. It gave you a password, and it gave you a few details about how to run that particular type of ad. Well, the first thing you can do is look at that page and check what ads that page is running. And you're going to see maybe one of these techniques that I've presented to you. Multiple ads, rotation of ads, and ads with slight variations. From that, we can take the content of the ads, pieces of text or important pieces of text, like let's say statements that we don't usually hear, like download this demo now because it's going to be removed. From that statement, we can pivot to searching for different ads that contain the same piece of text. From that, we go to their pages, and so on and so forth. And so, starting from just seeing one of these ads on social media ourselves, we can garner up quite a collection of pages and ads. I hope that answered your question. Yes, we have another one in the middle.
Thank you. Hello, thank you very much for the presentation. First of all, I would like to ask if you have any concrete examples of actually using AI to scan for the AI. Like, how do you tackle the issue of searching through all the ads that you identify on online social platforms, and how do you classify them after, and how do you determine score result?
Okay. I think I understood the question. So, when it comes to actually identifying which ads are the malicious ones and which ads aren't, while navigating to social media, we are able to save the videos we see. After saving all of these videos, using a speech-to-text model internally trained, we can extract the text from these ads. Of course, not all of these ads are going to be in the same language, especially if you're not from an English-speaking country. You might see ads in English or in your particular language. So, after extracting the videos, we go over each one and extract the text in these particular videos. Where the detected language isn't English, we're going to translate that text to English. After, we can assume that we have a collection of texts from all of these ads. Afterwards, we can run a model for predicting, for example, the topic of the ad. You most likely know that there are NLP models capable, that already exist, capable of predicting the topic of a certain number of sentences. For example, sports with a probability of 80%, or finance with a probability of 90%. So, after we have this collection of text, and we have ourselves the analysis of each one of those, we can start looking for patterns. For example, when we talk about, let's say, investment scams, because I know that you've asked me before this meeting about investment scams. These particular type of scams, when trying to identify their topic, of course we're going to see finance, but as we can see in the wild, we can also see particular names being thrown in there, particular entities that could be detected using named entity recognition. Well, when faced with a bunch of text classified with some topics and some entities, of course that we can create a way of finding patterns towards these scams. Also, when it comes to the identification of whether that text is a scam or not, because I assume you're also interested in that. Like I've said, using NLP, we can detect sensational language, we can detect people, or we can detect when the person in the ad tells you that you're going to double your capital, because we've heard that one a million times. These can be identified and can be, let's say, clustered together in order to form a general image of that particular video that we've seen, complete with its topics, its entities that we've identified, either names of persons, names of companies, or names of private entities, and we can check for the sensational language, and that would be an accurate way of finding such ads. Of course, you can always find false positives, but it's an incremental process, and tuning it leads to certain interesting patterns. I hope that answered the question. Yes, we have one in the last row there, in the corner of the room.
First of all, thank you for delivering such an interesting presentation. My question would be, I know a lot of people fall for big botch-bring scams and voice cloning. So what would you do in order to detect voice cloning, except, of course, for asking your friend if his message was authentic?
All right. I think I've also added that at some point when I talked about convolutional neural networks. Usually, when we're talking about convolutional neural networks, we all know that these networks over large quantities of data are able to make certain connections that help it understand whether, or that help it classify a certain type of video or audio message. Well, when we think about all kinds of generated audio, of course, generated audio, deepfaked audio, it's going to be slightly different in terms of frequencies from the legitimate one. So, like I've said, by training a CNN on large quantities of data, both real and both synthetic, it can learn to differentiate between the two. So, it can pick up on small, let's say, pauses in certain frequencies that indicate that a scam, that it's been tampered with, or that is AI generated. Thank you. We have another there.
Thank you for the presentation. This one is related to the other one. Can you name, or is there any available tool on the market that can analyze these pitches, these frequencies in the tone in order to be able to detect if we talk about a deepfake or not, or it's something that we should train and we should input all this amount of data?
I am not aware of tools available on the market. It's something we should train, but of course, at some point, it's clear that multiple will be developed, multiple of these types of tools. Does that answer your question? Well, thank you, everyone. And I hope you have a lovely rest of the conference. Thank you.
This break.